Hey everyone, welcome to the talk or the workshop on Accelerate API testing with AI automation. Before we get started, I'm just going to put it in the slideshow mode. All right. So once again, thank you for joining me here today with this session. I just want to congratulate you all. You made a great choice. So I am Swetha Sridharan, product manager with IBM API Connect. And today, like I said, I'm going to be talking about, why API testing and why you need to automate and use AI to accelerate your API testing. I'm sure some of you or all of you here can, would have figured out what this image is, right? Like it's the strategy chart of both the offense and the defense part of the same team and how they play well cohesively makes or breaks the team. Similarly, I would say the API development and API testing are like your offense and the defense strategy. They need to work really well for your API strategy to be paying off for you, and for you to put out great, reliable and trustworthy APIs for your consumers to start consuming. And that brings us to why API testing, right? Now, with enterprises adopting digital transformation at a pace that we haven't seen before, it's all because of APIs, and they have unlocked the potential to exchange data in ways we have never seen before. And to be successful in this disruptive climate, every enterprise has to constantly update to stay ahead of competition. So they have to be really fast in order to win, serve, and retain customers. And how are they doing it is by automating their DevOps pipeline, and that has truly changed the software development. And I would say it's gone a huge metamorphosis, right? The DevOps pipeline has automated the way the code gets dropped, code gets developed, and how fast they can take the software code to their customers or consumers, basically. Now, when we see the overall software development process, the development, or it is true for the API development as well. So the development part of it has been totally automated. You have the CI/CD pipeline, everything gets done in an automated fashion. But when it comes to testing, it has remained mostly manual. And with the increase in the frequency of code drops, it has almost become impossible for the test or the testing team to catch up with the changes because everything needs to be done manually. And clearly, a lot of us are struggling here between finding a balance between moving at speed versus quality. Now, let's see how we could, or how API Connect specifically and at IBM, we are addressing this major issue that we are seeing across different organizations. So we've introduced a feature or a tooling called the automated test tooling. And with that, what you can do is, or what it does, it automatically generates test cases just by looking at your API contract. You don't have to write code at all. It's the tests are generated with a single button click. Sometimes you may not have an open API contract or definition, and you don't have to worry about it. So even if you just have data on the wire with an endpoint, you could get started with generating this test automatically. And what this does is it generates test assertions or test cases based on your API semantics. It also comes with a visual test editor where you can add more assertions. As you're looking to test different scenarios, which includes integration testing, functional testing, and whatnot, you can easily sequence these API calls, use a lot of logical constructs, and test against various data sets to ensure that your API behaves just the same way. So all of this is made very, very easy for you. Easy for the developers, easy for the QA team to get started with. Now, the whole point of the talk, or the discussion, is how do we have these tests automated, right? I mean, what's the point of generating these tests if I'm not able to have them as part of my CI/CD pipeline? So we have addressed that issue through the ability to integrate the generated tests as part of your CI/CD pipeline through what we call as hooks. And using the hooks, you can call or look at what are the published tests, run specific tests either by IDs or tags, or you can run these tests by providing additional information like variable override. And it's also easy to integrate with a CI/CD tool like Jenkins, which is most popularly used, and we provide the support through the JUnit. So you could run these tests as part of your CI/CD pipeline. So every time some developer checks in the code, you can have these tests run as part of your script and make sure that the changes don't disrupt the behavior of your API. And finally, we have also provided integrated dashboards and test reports where you can take a look at the results, the end-to-end results, and how your API has been, the health of your API, basically, like how many passed, how many failed, to understand the trends in your API quality. I know we've talked quite a bit, so I'm going to take a quick pause here and show you exactly how this is done. As you can see, this is the automated testing feature that's available in IBM API Connect. This is also available as part of the Cloud Pak for integration. So this is one such instance that I'm using for this demo. Here's the main dashboard that you're seeing here. Gives you an overall understanding of how many test suites you have, how many tests, how many have passed, how many have failed. And there is a cool dashboard graphic here that gives you the visual representation of this information. So I'm going back to the HTTP client here. This is where you provide your information. Like I'm going to just use an endpoint for this demo, which I've already saved just to save time. So as you can see, this is my endpoint. I have given the client ID and secret, and I've made a call. And this is my response payload here. Now, just to give you a quick overview of what the response that you're seeing here, you have the headers, information in both raw and passed, and similarly body. Along with that, you also see that my status code is 200. I also have the latency fetch and the total time to understand how long it took for the API to return the requested payload. Now, what I'm going to show you is what we just discussed. Now, for me to create test case to test this endpoint, all I have to do is click on generate test. So here I'm going to give a test name. Let's call this starts. Either I can select a test suite that I've previously created, or I could just create a new test suite. Let's go with something called stocks. And as you can see, all I've done is just clicked on generate test, and the tool automatically is generating test assertions for me based on, like I said, the semantics of my API. So as you can see, The tool has generated the test assertions for me, where it's checking, for example, right? Like if the payload has time series and does it exist, and it looks for various other metadata within the payload, like information must exist, symbol must exist, and so on and so forth. Now, as a QA tester or a developer, you may want to add more assertions to this, right? So this is the visual test editor where you can add as many assertions as you want, and to your already generated test case. So let's say I'm good with what's generated for now, and then I want to quickly make sure that the test is working as it should. So I'm clicking on Run Test. There seems to be some issue with the stack today, so I'm going to use a different test to see if that works. Please bear with me for a second. It's, that's the beauty of the live demo. You never know when something stops working. So here I've already generated, a test case here. Oh, which would actually be a very interesting use case as well. So let's quickly run this test, and then I can walk you through what I'm doing here. As you can see, I've run the test. This is my test report, and at a glance, I can see that my tests have passed, which is great. And I can see the requests here, what's the status code, and see what's happening here. So which is all great. Now let's go back to that test case that I'm seeing here. Here's an interesting part, right? Like this is an endpoint which has been secured with OAuth, and I can use this tool to test a lot of OAuth's top 10 vulnerabilities. And here I can show you how to test for authentication and authorization. So here's a post call that I'm making to the I'm making the post call where I'm actually generating the token. So my grant type is password. This is my username, password. I have a client ID secret, and I've set a scope. Now let's first start with the authentication. You need, what's authentication, right? Like when the username and password doesn't match, this test case has to fail. Now let's see if it does, right? I'm going to change my password value. I'm hoping this test should fail, right? And it did. See, I got a 400 because obviously my username and password is not right. So it says unauthorized, which is perfect. So it's working as it should. Now let's change this back to the right password. And I'm going to change the scope, which is the checking for the authorization bit, right? Let's say if the endpoint that I'm trying to call only has the scope as update, I'm going to change it to read and see what happens. It's failed, right? Even though I was able to generate the token successfully in the first step, because the token has both read and update scope. My OAuth has both read and update scope. This particular post endpoint has only update and not read. So that's why you see that even though my token has been generated in the previous step, my post or my actual call to the endpoint has failed. And like I said, we have the dashboard view here where you can take a look. It gives you a unified view of the runs, how many have passed, how many have failed, with lots of filters here. where you can provide the custom time range, and so on and so forth in terms of tags, locations, to filter the data that you see here. So this looks a great starting point, right? So, if you're starting on your API testing journey, this is a great starting point where you have the ability to automatically generate tests, get you started, use those tests as part of your CI/CD pipeline, and make sure that you address the guaranteed scenarios in your testing with the automated test generation. Now there are let's think about this, right? Like as you have APIs in productions, what happens, right? Like as you have more APIs in the production and you have consumer applications invoking the APIs, and they do that via an API gateway. Now, this API gateway acts as the gatekeeper, or let's say the entry point that enforces security control, access, rate limits, and whatnot as the client applications are trying to invoke the API. Now, the consuming API spec in the form of Swagger or OpenAPI 3 definitions that defines the request, response, and all of the parts and operations, right? And just now we saw that we have the automated testing capability as part of API Connect that lets you to author these tests, that invoke the APIs through API Gateway, and you have the automated tests. You can run those automated tests to make sure that the spec is intact, right? Like the behavior defined in the spec is intact. Now, this model of testing is, like I said, is great to start with, but it doesn't provide you the external view of the API contract. So you don't know if there are any potential errors or weak points in the implementation that arises from the API. So now with the increasing adoption of microservices, the implementation of the API typically involves a lot of interactions, as depicted here in this chart. So you have different components that are not visible to the external consumer, but they have a dramatic impact on the system, right? The API could call a backend, which can then put a message in the message queue, and then it could call the integration flows and whatnot. There are like various permutation and combination, and especially with the adoption of microservices, this is becoming more and more evident, right? Now, let's consider a complex API management system. So here, an API is exposed in the API gateway, and this might request this might route a request to the backend API, which might then invoke an integration flow, which then calls for some type of a backend systems and finally puts a message in the message queue. So this is one such example, and there can be much, much more, right? So it's not enough to just test the individual parts or services. You need to test the interactions that happen between these different components that we just saw. And the reason why you need to test is because you need to figure out if there are any errors to prevent regressions and to accelerate development. And this is even more critical, especially when you have a lot of microservices in your environment. Now, authoring these tests, like I said, can be consuming because it's not easy or very, very evident to capture these interactions that happen between the microservices and application. And also, what's been covered and what still needs to be written is something that a QA person or the QA team has to figure out, which is again a lot of consumes a lot of time. So what we have come up with is called the AI-powered API test generation. So what it essentially does is it understands or it identifies the gaps in your test coverage by finding patterns that are not already covered. So how does it do? I'm going to talk about how it does in just a bit. So it's basically, it's going to identify those gaps for you, saves you a lot of time by not only identifying those gaps, but also automatically creating tests to address those gaps as part of your test coverage. And this is by finding patterns in your test workload compared to what's already there in the production workload. So we use something called the open tracing or telemetry data to help us achieve this. So the telemetry or the open tracing data is nothing but a way of capturing a sequence of interactions in a distributed system like we just saw. So it can capture each of the different calls made to these different service. Now we look at the production workload to identify what are the real world usage patterns. And then we collect the equivalent telemetry or the open tracing data from the test environment. And then what we do is we have the insights or, which uses machine learning to understand or detect the gaps between the test workload and the real workload. Now, for example, right, an API call that makes an order might result in a call to, let's say, a delivery microservice to arrange delivery. But the same API call, made with, let's say, a premium membership who pays annual subscription for a fast delivery might result in a different delivery microservice call. So you need to, or the system needs to understand that these type of interactions needs to be accounted when you're actually testing. So what we have done is basically after you compare the workloads, like after the insights compares, what's there on the production trace data versus what's there on the test trace data, it automatically recommends and generates new test cases to address those gaps in your test environment. In a nutshell, what we have done is we have used closed loop automation to detect the gaps between your real workload and your test workload and create higher quality tests with minimal manual intervention. I'm sure you're all curious to see the demo of how we do this. I'm going to be, unfortunately, my live stack has gone down. So I'm going to be using a recorded demo of how, the insights, the AI insights works. So I'm going to be sharing that in just a bit. But if you're all interested to learn more about how, automation and AI in API testing is important and needed to create reliable APIs, do check out our white paper out there. We have, talked a lot in detail about why API testing and why automation in API testing. So please do check it out. So demo time again. As you can see, here's the recording, but this is an end-to-end demo that we have recently did. So unfortunately, I'm going to be using it because my live stack has gone down. Again, the joys of using or doing a real-time demo. So here, as you can see, we have the This is the main page that you see here, um, with a few test suites already created. But I'm going to be showing you using the TechCon stack, where we have enabled the insights. So here's where we have enabled insights, where we provide the Agar information. So this is the open tracing. We use Agar for collecting open tracing data. So here's where I provide all the settings information related to running the insights. We have Hager, we can, and then we provide the data service, like basically look at the analytics data to capture these different interactions from our production environment. So once I've done that, I come back to, so once I've enabled that, I'm gonna say I've saved my settings, and now let's go to the tests. Now, as you can see, I have my insights is running right now with the settings that I've just set. So what insights is doing, it's running the models on the production analytics data to figure out, and then it's again comparing with my test source to test environment to figure out what are the gaps. It's taking a bit of time because again, it's this was done at real time to understand. We are actually training the model on the data here, so that's why it's taking a bit of a time. So it's actually working here right now. So once this is run, you can actually see that the insights would provide us recommendations. All right. So as you can see here, the Insights has provided us with a set of recommendations. Um, Now, one thing that I do want to call out is here you see an impact score, but not a confidence score. We don't give out a confidence score because every single behavior that we've captured is legit. Hence, confidence is 100%, right? Now, what I do want to quickly show you is, let's see what's there in the view detail. Okay, sorry. So this is actually providing me recommendations for get books. Um, this is probably like one of the top uh, the first one that the Insights has provided here. When I click on view detail, here's the behavior in particular we want to capture in our test environment. Now here, every single step that you see here is either a microservice calling another microservice, or these are internal calls between like different methods that you see here. Now, um, I do want to, let's say, I'm good with the recommendations, and now what I'm going to do is I'm going to be, adding this test case to my test suite here. So I click on add test case and I am providing the test name. And as you can see, the tool or the AI insights automatically, it generates the test case for me here. So with that, we've talked about how or why API testing is important, and why is it ripe for automation use and AI, and how AI and automation can help you make testing a lot more interesting. So I really hope you have enjoyed the talk and the demo that we did. So with that, I am opening the floor for any questions that you may have. Any feedback, comments, or anything on the chat? If you're interested in talking more about API testing or IBM API Connect or anything in general, feel free to reach out to me. Happy to take calls and talk to you all on one of my interesting subjects, which is again API Connect. Any questions? I'm going to be hanging around for a couple of more minutes just to see if we have any questions from the audience. If not, I'm going to be wrapping up the call. I'm wrapping up the talk in like 2 minutes. I don't see any questions so far. All right. Thank you all so much for being here. Hopefully, we'll catch you in another talk in another time. See you all. Hope you have a good rest of your day.